Hi, I'm Dr. Fletcher Perry from Examsolutionprovider.com. Today, I'll be looking at maths as related to nursing in terms of applying maths in calculation of doses for medication for patients. Giving patients correct doses is extremely important in medicine. Whether it's a doctor or a nurse, medication need to be prescribed correctly. Medication are calculated, or medication doses are calculated based on the weight of the patient. So most of the doses you realize they are going to be per kilogram or per any measure of the body weight that actually is being used. Medication are both good and dangerous. They are foreign bodies, therefore they can damage our body, particularly if we are not given the correct amount. There's also quite a common problem in terms of what is called medication errors, and the medication errors can be fatal. They can actually kill the patient. If patients are given not enough doses or enough medication, then they will take longer to get better, or their conditions will get worse. So it's extremely important that they get correct amount of medication based on their weight. If they are given too much, then it's going to damage our liver as well as other organs in the body. As I've already said, obviously they can cause death or even damage with a poor prognosis or some complications in our patients. Some patients are more vulnerable to medication than the others. Therefore, we need to pay more attention, particularly when we are giving medication to children and also giving medication to elderly people and also those who have what underlying conditions, including pregnant mothers. So all these need to be taken into account. Medication errors are very common in the hospital, in nursing home, and in any other settings where people are expected to be given medication. Okay, so we know that the nurses, they require to know some maths. Okay, at least they should have a GCSE maths, and this GCSE maths is to help them to calculate doses correctly. Now, this video was actually prompted by tutorial support that I was giving my wife, who is undergoing studies in as a nursing associate. I think they call themselves, nursing associate program, right? Which in their program, one of the modules they require to calculate medication. So she found the tutorial support I gave her very useful, and definitely it has helped her because she has been very successful in her exam. Therefore, she prompted me to see whether other people might obviously benefit from this material. So I'm going to look at a few questions, going through questions with you, which obviously I use to help my wife prepare for the exam. Any other person who might be pursuing a course which require calculation of the doses obviously can benefit from this video. It's more probably like a revision. Okay, so let's start with the first question. All right, so the first question says, a patient is prescribed erythromycin 12.5 milligram per kilogram body weight. So is 12 12.5 milligram per kilogram body weight. That's what the patient has been prescribed, and this is erythromycin. Okay, right. And also he has got to receive this medication QDS. QDS, you know, hospital people like these abbreviations quite a lot. QDS means 4 times a day, so he's receiving this dose 4 times a day. And the patient is 90 kilograms, so the patient is weighing 90 kilograms. Okay? Now, what they are asking is how much erythromycin will they have in total today? Okay, so how much of erythromycin will they have in total? Okay, right. So this is what the questionnaire is. Sorry, our doctors write rubbish, so our handwriting is always not a good one. So forgive us for that. But the more I'm talking, the more you'll be able to follow what I'm talking about. Okay, so what you need to do is look at this one here. Okay, that's the most important. All right. So change this into equation that obviously you were used to do when you were doing your maths in GCSE. Okay, so per kilogram. So if this patient was 1 kilogram, okay, what he would get, so it's equal to, which means he will get 12.5 milligrams. Okay, yeah. So that's your first part. So if it was 2 kilograms, you can see you need twice of this. Okay, so we will multiply this by 2. If he had 3 kilograms, then we would multiply this by 3. Now this patient is 90 kilograms. Okay, so therefore we need to multiply this by 90. 12.5 times 90. Okay, but remember he is actually receiving this medication 4 times a day. So this only the single dose, but 4 times a day, which we're going to give a total. Then we need to multiply the whole of this by 4. So the answer we get is going to be milligram. Okay, so that's the way we should work. Then modern days easier. Okay, there are calculators. So we take calculator. Then we have 12.5. We are multiplying by 90. And multiply by 4, then I will get the answer as 4,500. So this will give me 4,500 milligrams. So that's the total, how much this patient need to receive. All right, I hope that helps. Okay, let's go to okay, let's look at the next question. Now, the next question says a patient needs 90 mils. So this patient needs 90 mils of codeine in a 24-hour. Okay. Yeah, in a 24-hour period. Right. They require every 4 hours. Okay. Then the question is, what dose will they have? Okay, so that's our question there. Okay, right, so let's look at this question carefully. Right, so this patient needs 90 mils of codeine in a 24-hour period. And then they are receiving it every 4 hours. Okay. The question is, what dose will they have? Okay. So we know 90 mils is the total that a patient needs to receive in 24 hours. So 90 mils needs to be received in 24 hours. Okay, that's the total that you need to receive in 24 hours. Now we know he's receiving every 4 hours, so he's receiving this medication every 4 hours. Now, in how many times does he receive in 24 hours? So we need 24 hours divided by 4. If we divide by 4, we'll get 6 times. So he gets 6 times. Okay. Now, to find the dose that he will need, that we need this each time. Okay. So this need to be spread over 6 times. So therefore, we need to divide 6 into 90 mils. So 90 mils divided by 6, that will give us 15. Yeah. So 15 mils, that's the dose. So he's going to be receiving 15 mils. You can see if he is going to receive 15 mils each time, okay, for 24 hours, yeah, he's more likely to get 90. So 15 times 90, 15 times 6 should give you 90. So he's going to receive 6 times because he's receiving every 4 hours. And then obviously 6 divided into the total that he needs. So each dose is going to be 15 mils. So each time the nurse goes to give the medication, is going to give 15 mils. Okay. Right. Okay. Let's try. The next one says a patient is prescribed oral morphine 2.5 milligrams. Okay, this is oral morphine when it's necessary to relieve the breathlessness. Now, the preparation you have, so I say if you have, okay, so if you have 10 milligram per 5 mil morphine. So this is the way suspension you have. So, okay. Now the question is, so that's what you have. What volume of suspension do you have to draw into the oral syringe for administration to the patient? Okay. Right. So what volume do you need to draw up, okay, into the syringe so that you can give the correct dose to the patient? All right. So this is the preparation. That's the way the preparation is. But this is the dose. So the prescription. So it has been prescribed 2.5 milligrams. Okay. But the preparation of your bottles, they are actually 10 milligrams per 5 mil. Okay? Again, the maths you did in GCSE, we need to look at this one here. Okay? So what we know is 10 milligrams, all right, is equal to this 5 mil here. Okay? So it's equal to 5 mil. Okay? So my interest is to find what would be 1 milligram. How many mils will be 1 milligram? So to get 1 milligram, I need to divide this side by 10, and I need to do the same here by 10. Okay? So this cancels, which means I have 1. So I have 1 milligram, which means it's 5 over 10 mils. Okay? So for every 1 milligram, 1 milligram, okay, I will need to, okay, the amount I get is 5 over 10. But I have 2.5, so which means I need